Assalamualaikum and hi everyone. In this video, we are going to discuss about isomerism. Isomerism is the existence of compound with the same molecular formula but different structural formulas. Isomers are compounds that have the same molecular formula but different structural formulas. We have two types of isomer. The first one is structural or constitutional isomer, and the second one is stereoisomer. So today we are going to focus on the structural or constitutional isomer. Constitutional isomer can be divided into three types. The first one is chain isomer, the second one is positional isomer, and the third one is functional group isomer. So, constitutional isomers are different compounds that have the same molecular formula but differ in their connectivity, that is, in the sequence in which their atoms are bonded together. Let's look on what chain isomer is. The isomers differ in the carbon skeleton or different in the longest carbon chain. They possess the same functional group and belong to the same homologous series. They have the same chemical properties but different physical properties. So this is example for chain isomer. Draw all the chain isomers of C5H12. So C5H12 is the molecular formula. So all isomers that we are going to draw should have 5 carbon atoms and 12 hydrogen atoms. So this is the first structure. We have 5 longest continuous chain of carbon atom for the first structure. So this is pentane. The second structure is 2-methylbutane, where we have 4 longest continuous chain of carbon atom with 1 methyl group attached to the carbon number 2. Okay. And the third one, we have 2,2-dimethylpropane, where we have 3 longest continuous chain of carbon atom with 2 methyl groups attached to carbon number 2. So this is 2,2-dimethylpropane. So all these 3 isomers have the same molecular formula, which is C5H12, but different in their carbon skeleton. Okay, pentane, we have 5 carbon, longest continuous chain. 2-methylbutane, we have 4 carbon for the longest continuous chain. And 2,2-dimethylpropane, we only have 3 carbon atom for the longest continuous chain of carbon atoms. Okay, the second type of constitutional isomer is positional isomers. These isomers have a substituent group or functional group in different position in the same carbon skeleton. For example, if we look at the structures, the positional isomers for C5H11Cl, for the first structure, 1-chloropentane, okay, chlorine attached at carbon number 1 in the parent chain. Okay, while in 2-chloropentane, the chlorine atom is attached to the parent chain at carbon number 2. And for 3-chloropentane, the chlorine atom is attached to the parent chain at carbon number 3. Okay, so these 3 structures have the same carbon skeleton. Okay, all these three structures are pentane, which have 5 carbon atoms as the longest continuous chain of carbon atom, but the difference is the position of chlorine that is attached to the parent chain. Okay, the position of a chlorine or functional group that attached to the parent chain. So this is the example of positional isomer. The third type of constitutional isomer is functional group isomers. These isomers have different functional groups and belong to different homologous series with the same general formula. Different classes of compounds that exhibit functional group isomerisms are alcohol and ether. The general formula is CnH2n plus 2O. Aldehyde and ketone. The general formula is CnH2nO. Carboxylic acid and ester. The general formula is CnH2nO2. And alkene and cycloalkane. The general formula is CnH2n. So how to identify whether the compound consists of functional group isomers or not? You need to see the molecular formula and convert the molecular formula into the general formula. Okay, only these 4 general formulas are involved in functional group isomers. If you found general formula other than this, that means there is no functional group isomers. So we have 4 pairs here: alcohol and ether, aldehyde and ketone, carboxylic acid and ester, and alkene and cycloalkane. Only these 4 pairs will involve in the functional group isomers. Okay, that's all. Thank you for watching.